Hello everybody, this is the notes for Advanced Geometry, section 3.6. This is the last section of this chapter. We'll be talking mostly about perpendicular lines and just some of the characteristics of them and some of the properties that happen when you have perpendicular lines. You're also going to be finding the distance between a point and a line and the distance between two parallel lines. Alright, I'm going to do two videos. The first video is going to be all notes. So I'm just going to go one theorem at a time, hit pause, copy down this first one. All right, so this first theorem says, if two lines intersect to form a linear pair, okay, again, linear pair, two angles that are adjacent to each other, they have to be 180. If those two angles are congruent, they add up to be 180 degrees and they're equal, they got to be 90 degrees. So what they're saying is that line is going to be perpendicular, or that the two lines are going to be perpendicular. Okay? So I mean, it's something that we've talked about before, we've done in problems, but it's a theorem. We could prove it if we wanted to. But that's just one theorem. Okay, hit pause, copy down theorem 3.9. All right, for this one, it says if two lines are perpendicular, then they intersect to form four right angles. So you got perpendicular lines. There's one right angle at angle 2. You got vertical angles. Means angle 3 is going to be 90 degrees, so it's going to be a right angle there. For 2 and 4, you've got a linear pair. One of them is 90 degrees, forces the other one to be 90 degrees. Vertical angles gives you angle 1. So basically it just says when lines are perpendicular, you're going to put that perpendicular marker in there, but all four angles at that intersection are going to be right angles. Okay, kind of obvious, but all right, theorem 3.10. Please copy that down, hit pause. All right, if two sides of two adjacent acute angles are perpendicular. So what they're saying is, you have these adjacent angles, angles 1 and 2, they are sharing this ray. They have the same vertex, point B, so they are adjacent to each other. If two sides of two adjacent acute angles are perpendicular, so side AB and side BC, if those are perpendicular and angles 1 and 2 are adjacent, meaning there's no overlapping part or anything like that, angles 1 and 2 got to be complementary. Okay, again, kind of an obvious one, but it is a theorem. All right, go ahead, hit pause, copy down theorem 3.11. This one says, if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to each other, or to the other parallel line. So you've got line J, it is perpendicular to line H. Now, if line H is parallel to line K, then corresponding angles are equal. So that means this is another right angle down here, and so line J has got to be then perpendicular to line K. So if you got parallel lines and that transversal is perpendicular to one of those lines, it's going to be perpendicular to the other parallel line. Okay, hit pause, theorem 3.12. All right, this one says if you have two lines perpendicular to the same line, okay, line M is perpendicular to line P, line N is perpendicular to line P. If those two lines are perpendicular to the same one, then these two lines are going to be parallel to each other. Okay, what we have here is the corresponding angles converse theorem. Right angle here, those two angles are congruent to each other. They are in the corresponding angle position. Because the corresponding angles are congruent, it means the lines are parallel. Okay, so now we are here. Go ahead, hit pause, copy down this in the picture, probably the distance form at the bottom also. So when you measure a distance, it doesn't matter what you're measuring, whether it's the height of something or how far something away is, you always start at a spot, a point, and you go perpendicular to the object. If there is a wall here, and you're standing over here, and you want to measure how far you are away from the wall, you don't go over to here. That doesn't make sense. It's further than you actually are from the wall. You always go perpendicular to that object that you're measuring the distance from. And so in this class, the idea is if you have a point, A, looking at this picture here on the left, and you got this line, K. To measure the distance from point A to line K, you go from A, perpendicular to line K at point B. All right, you always measure a distance perpendicular to the object. Now, if you're trying to find the distance, looking at this second picture here, if you're trying to find the distance between two parallel lines, pick a point, doesn't matter, we'll start at C, and you go perpendicular to that other line. Same thing, if you're at point F, to measure the distance from point F to point E, you go perpendicular to the other line M. So now, to find the distance, you need to know 2 points and your distance formula. We talked about that last, I think in chapter 1. Okay, the next video is going to be just examples, work through. Thank you. Drive through.